Okay, now we have been doing problems on different aspects. Now, another problem which is very useful, that for Newtonian and non-Newtonian fluids, right, we have done flow through Newtonian, flow through pipes, flow through slits for Newtonian fluids. We have also done flow through pipes, flow through slits for non-Newtonian fluids. Now, and in the non-Newtonian fluid, it follows the power law equation, and there we have seen that the flow behavior and consistency coefficients or indices, they are having tremendous effect on the flow characteristics, right? But we also need to know what could be the values which are normally we handle with. For example, if it is Newtonian fluid, then the value of n is 1 and the viscosity is the k, that is the consistency coefficient. We call it to be that viscosity. But if it is not Newtonian, if it is non-Newtonian, then both the consistency coefficient and the flow behavior index or indices, this we must have some idea about the values, right? So, let us do also some problem to be solved or problem solution such that we have some idea on that. Okay. So, let us look into this problem that a fluid is flowing through a tube having an inside diameter of 0.008 meter and a length of 0.3 meter at a flow rate of 5 into 10 to the minus 5 meter cube per second, and thereby induces a pressure drop of 1000 Pascal. Calculate the apparent viscosity as defined as the viscosity of a Newtonian fluid which exhibit the same pressure drop as this fluid at the rate of flow through this tube. This is one. Then, if the flow rate of the fluid is 1 10 to the minus 4 meter cube per second and the length of the tube is reduced to 0.2 meter, keeping the same diameter induces a pressure drop of 2000 Pascal, what will be the flow behavior and consistency indices of the fluid, right? So, if we reread, the problem is like this: a fluid is flowing through a tube having an inside diameter of 0.008 meter and a length of 0.3 meter. So, inside diameter d is equals to 0.008 meter and length L is equals to 0.3 meter at a flow rate of 5 10 to the power. So, Q is equals to 5 into 10 to the power minus 3 meter cube per second, thereby induces a pressure drop. So, delta P is equals to 1000 Pascal. Calculate the apparent viscosity defined as the viscosity of a Newtonian fluid which exhibit the same pressure drop as this fluid at the rate of flow through this tube. Second, question, if the flow rate of the fluid is 1 into 10 to the power minus 4 meter cube per second and the length of the tube is reduced, so L is 0.2 meter, the same diameter induces, keeping the same diameter, that is D is equals to 0.008 meter, and induces a pressure drop, so delta P is equals to 2000 Pascal, right. What will be the flow behavior indices and the consistency indices of the fluid, right. So, this we have to do. So, let us solve it. Now, for solution, I think you may have a little problem in this. Let me try. Now, from the Hagen-Poiseuille's equation, which we know, which we know that delta P is equals to 32 mu V average L by D square, right. So, this is the delta P. Okay. Therefore, from there we can write that V average is equals to delta P D square by 32 mu L, that can be written as delta P R square by 8 mu L, right. So, if we call it to be equation number 1, right. Now, this equation can be used to determine the viscosity of non-Newtonian fluid if the viscosity obtained will be apparent, and viscosity this will be apparent viscosity and using a single rate of flow, and in that case we can say mu apparent is equals to delta P R square by 8 V average into L, right. So, given D is so much, so R by 2, rather D is so much, so is equals to 2R, should not be R by 2, is equals to 2R, right. So, R is equals to 0.004, right. So, if we write that value, we can say the delta P given is 1000, R is 0.004 square 8, right. Now, V average, that can be found out from V average is equals to flow rate has been given, that is Q over area, cross sectional area, right. So, if we say that this is equals to flow rate has been given Q 5 10 to the minus 3, 5 10 to the minus 3 meter cube per second, and area is pi R square, pi 0.004 square, right. So, this is we get so much meter per second. So, if we apply that 8 V average is that So 8 into pi into 0.004 square, right? L given is 0.3 meter, right? So we can write that this is into 0.3 and this is already done. This is so, and here pi into did we do wrong? Yes, we have done wrong. 1000 into 0.004 square by 8. V average is that. So into 5 into 10 to the power minus 3 in the denominator, right? Into L is 0.3 into numerator is pi, and this is 0.004 square. Okay, so this comes to equal to, let us look into that. Thousand into 0.004 square, this much, into pi into 0.004 square, this much, divided by 8 divided by 5 divided by 10 to the minus 3 divided by 0.3 is equals to 6.7 10 to the power minus 5, so much Pascal second, right? 6.7 10 to the power minus 5 Pascal second. Why it is 10 to the power minus 3 is coming here, 10 to the power minus 3. It is pi 0.004 square 5 10 to the minus 3 meter cube per second. This is meter square. So 1000 delta P 0.004 square pi into 0.004 square, fine, by 8. V average is this 5 10 to the minus 3 and the L is 0.3. So somewhere again you have done little wrong. Let us look into 0.004 square into 0.004 square is equals to this much into pi into 1000, this much divided by 8 divided by 5 divided by 0.3 divided by 10 to the minus 3. Yeah, it is coming 6.7 10 to the minus 5, right? So perhaps here we have done something wrong. V average is coming 0.995. Let us see once whether V average is coming 5 into 10 to the power minus 3. Yeah, divided by pi divided by 0.004 square is equals to 99.47. So that was something wrong which was done here. It's not pi. So there it comes. It is correct. Okay. So mu apparent is so much. Then next week what we have to find out is second case. First case we have been asked that what is the mu apparent, right? The apparent viscosity we have found out. Now second case we have to do that V average second case we have to do V average. This is equals to 1 10 to the minus 4 q divided by pi to 0.004 square, right? This is equals to 1 into 10 to the power minus 4 this much divided by pi this much divided by 0.004 square this, so 1.989, so 1.99, right, meter per second. So if it is so 1.99 meter per second, then we can write mu apparent, right? So mu apparent how much? It is coming for 2000 delta p into r square 0.004 square divided by 8 into V average. V average is 1.99 into L is 0.2. So this comes equal to 2000 into 0.004 square, that is this much, divided by 8 divided by 1.99 divided by 0.2, 0.0100, right, 0.01005, right, so much Pascal second. So that can be said 1.005 to 10 to the power minus 2 Pascal second. So mu apparent, right? Now we can say that shear rate at the wall, that is at R is equals to R, a Newtonian fluid is minus dV dr at the wall is equals to 4V average over R, right, where as for a non-Newtonian fluid, whereas for a non-Newtonian fluid, mu apparent is equals to K to gamma to the power n minus 1 and minus dV dr at the wall is equals to V average into 3n plus 1 over n into 1 by r. That can be written as 4 V average divided by r into 3 by 4 plus 1 by 4 n, right, or we can say gamma at wall W is equal to 4 V average divided by R times psi, so where we can say psi is equals to 3 by 4 means 0.75 plus 1 by 4 means 0.25 over n, right. So, mu apparent we can write to be K into 4 psi divided by R to the power n minus 1 V average to the power n minus 1, right. Now, if we use 1 and 2 for subscript for velocity and corresponding apparent viscosity, then this is at viscosity means at 5 10 to the minus 5 meter cube per second and 1 10 to the minus 4 meter cube per second, right. So, for this to flow, if we use 1 and 2 as the subscripts, then we can write that mu apparent 1 over mu apparent 2, this can be written as K into del 4 psi by R to the power n minus 1 V average 1 to the power n minus 1 divided by K 4 psi divided by R to the power n minus 1 V average 2 to the power n minus 1, right. So, this is nothing but V average 1 by V average 2 to the power n minus 1, right. So, if we take log in both the sides, so we can say log of mu apparent 1 over mu apparent 2, this is equals to log of V average 1 over V average 2 to the power n minus 1, or we can write substitute the values log of 6.7 10 to the power minus 3 divided by, it was 6.7, it was 6.7 10 to the minus 5, not minus 3, 6.7 10 to the minus 5 and second one we got to be mu apparent 1.005 into 10 to the minus 2, right. This is equals to n minus 1 log of V average is equals to that we have found out average V. This is in one case we have gotten average V to be 1.99 in one case, and in other case we have seen here it to be 5 10 to the minus 5 by pi 0.004 square, right. So let us look into that. 5 into 10 to the minus 3 to the 3 plus minus is equal to divided by pi divided by 0.04004 square. So that is 99.47, right. 99.47 meter per second, right. So that if we substitute here, that log V average 1 was 99.47 over 1.99, right. So we can say then 6.7 10 to the minus 5, 6.7 into 10 to the power minus 5 is equal to this divided by 1.005 into 10 x to the power minus 2. This is equal to this, right. So log of zero point 0066 is equals to n minus 1 into log of 99.47 by 99.47 by 1.99 is equals to 49.98, right. So n minus 1 is equals to log of, that means let us put that 49.98 log 49.98 log is this much divided by 0.0066 log is equal to minus 2.18, right, minus 2.18. So n is equals to this plus 1 minus 1.18. Just check whether this value is correct or not. Okay, today we will continue in the next class. Thank you.